Discussing about the average power and the total power in an AC circuit, let us take an AC circuit containing the resistance and a reactance, either L or C. Let us take the case of a resistance and an inductance. Because we are having an inductor, that means the EMF leads the current by a phase angle, or the current lags behind the voltage or EMF by a phase angle. Now let us talk about the average power and the total power. Now if we have E is equal to E0 sine of omega t, as the circuit contains a resistor and an inductor, therefore there is a phase lag. That means I will be equal to I0 sine of omega t minus phi, where phi is the angle by which the current lags behind the voltage, or by which the voltage leads the current. Now let us talk about the total power. The total power PT will be equal to average power PAVG into time. The time T is for a full cycle. Now the average power is equal to integration of 0 to t E I dt, where E is the EMF and I is the current. Now from here let us put the values. So here PT will be equal to integral of E is equal to E0 sine of omega t, I is equal to I0 sine of omega t minus phi into dt. This is to be integrated from 0 to t. Now E0 and I0 are the maximum or the peak values. Those being constant can be taken out of the integral sign. So PT total power will be equal to E0 I0 integral of 0 to t sine of omega t minus phi into dt. Let this be equal to A and this be equal to B. We are having an trigonometric identity, that is minus twice sine A sine B equals to cos of A plus B minus cos of A minus B. We will change this sine A sine B to minus twice sine A sine B by conversion, and that will be equal to then cos A plus B minus cos A minus B. So PT will be equal to E0 I0 integral of 0 to t minus twice sine of omega t minus phi into dt. As we have got the product of minus 2, we will divide this one by minus 2. We will divide E0 I0 by minus 2, as this minus 2 and minus 2 cancels. We will get the same equation. Now this becomes twice sine A sine B, and that is equal to cos of A plus B minus cos of A minus B. So our PT comes out to be E0 I0 divided by minus 2 integral of 0 to t cos of A plus B. A is omega t plus B is omega t minus phi minus cos of A minus B, that is omega t minus into minus phi becomes plus phi, and this is to be integrated with respect to time, that is dt. Now solving it a little further, we have got this equal to minus E0 I0 divided by 2 integral of 0 to t, that becomes equal to cos of twice omega t minus phi minus cos of omega t, and omega t cancels out. This is cos of phi dt. Now we will integrate this one and integrate this one by one. So our PT becomes equal to minus E0 I0 divided by 2 integral of 0 to t cos of twice omega t minus phi dt minus integral of 0 to t cos of phi dt. Let us name it as I1, let us name it as I2. We will solve I1 first and then I2 first, then we will substitute here the value of the integrals and we will have the value of the total power. So integrating 0 to t cos of 2 omega t minus phi dt. We know that integral of cos is equal to sine, so we will be having sine of twice omega t minus phi, then internal integration of twice omega t is 1 by 2 omega. So we have 1 by 2 omega from 0 to t. The integral becomes, taking 1 by 2 omega out, we will substitute the limits of the t. So we are having sine of 2 into 2 pi by t into t minus phi minus lower limit, that is sine of twice omega into 0 minus phi. That is equal to 1 by 2 omega into this t and t cancels out. This is sine of 4 pi minus phi minus sine of minus phi. We have from the trigonometry, we have sine of 2n pi plus theta equals to sine of theta, and sine of minus theta equal to minus sine of theta. Putting it here, this term will be equal to 1 by 2 omega into sine of minus phi minus sine of phi. Now taking this minus out, it is 1 by 2 omega into minus sine phi plus sine phi. Cut this and this cuts out. This is equal to 0 addition of sine phi and minus sine phi. So that is equal to 0. That means the integral I1 is equal to 0. Now solving for the integral I2, that is I2 is equal to integration from 0 to t cos phi dt. Now we are integrating with respect to time, that means this cos phi, that is a number, it is a constant. So taking cos phi out of the integral sign, so we have cos of phi integral of 0 to t dt. That is equal to cos phi into t with the limits 0 and t. Now I2 will be equal to cos of phi into t minus 0. That will be equal to cos phi into t. That means we have got the value of integral I2 as cos phi into t. Substituting the integrals in here, we have got pt is equal to minus e0 I0 divided by 2 into 0 minus cos of phi into t. This minus and minus are in product, that is minus minus is equal to plus. So pt will be equal to e0 I0 divided by 2 into cos of phi into t. This is the equation of the total power. So the equation of the total power is e0 I0 divided by 2 into cos phi into t. Now we also have that pt is equal to p average into time. That means pt is equal to e0 I0 divided by 2 into cos phi into t is equal to p average into t. This time and time cancels out t and t, so p average power is equal to e0 I0 divided by 2 into cos of phi. Now solving it a little bit, we have P average is equal to E0 divided by root 2 into I0 divided by root 2 into cos of phi. We know that E0 divided by root 2 is equal to ERMS, I0 divided by root 2 is equal to IRMS. That means P average is equal to ERMS into IRMS, where RMS is the root mean square value, into cos of phi. So the average power is equal to ERMS into IRMS into cos of phi. Now let us discuss the terms related to this. We have got true power. True power is equal to ERMS into IRMS into cos of phi. Now this ERMS into IRMS is equal to apparent power, phi being the phase difference, and cos phi is equal to power factor. So we have that true power is equal to apparent power into power factor. If the circuit is resistive, that means phi is equal to 0. That means cos phi is equal to 1. If the circuit is containing resistances only, in that case cos phi is equal to 1. So the power factor is equal to 1. In that case, true power equals to apparent power. So when we are having a circuit that is containing resistances only, in that case true power is equal to apparent power, because the power factor is equal to 1. That means the phase difference between the voltage and the resistance is equal to 0. When a circuit is purely inductive or purely capacitive, the phase difference is equal to 90 degrees or pi divided by 2. In that case power factor is equal to cos of 90, that is equal to 0. So if the power factor is equal to 0, in that case the true power is equal to apparent power into 0. So true power is equal to 0. That means when we are having a circuit that is containing the capacitance only, pure capacitance only, or pure inductance only, in that case the passage of current through that circuit doesn't need any power. That current is called as wattless current. Thanks.